Hi guys, this video is about example on chapter 2, free vibration, single degree of freedom. So, based on this figure system, given it has pulley and also mass. So, the first equation is, what is the magnitude of the static deflation of the spring? Using the equation of moment equal to 0, the two forces exerting on the system are the spring force and the weight force, where moment is equal to time distance. So after inserting into the equation, the del ST equal to 9.39 mm. Next, B. A simple undense spring mass system is set into motion from rest by giving it an initial displacement. The first question is, draw the FBD of the system by showing all active forces acting on the body. Based on the system, two FBD must be drawn. The first one is for this, and the second one is for mass. This consists of two forces, which is spring force and tension force, while for mass, which is linear, is also consists of two forces, which is tension force and weight force. Next, obtain the equation of motion of the system by using x the generalized coordinate. Based on this equation, we have two conditions of the system, which is when statics and also when in dynamic conditions. The first one in static, state the pulley equation and also mass equation using moment equation and force equation, and then substitute equation number 2 into equation number 1, that will provide equation number 3, which is negative k del STR plus mg 2r equal to 0. Next, for dynamic part, we need to write the pulley equation and also mass equation. Mass is in downward positive, that will provide equation number 5, and then substitute equation number 5 into equation number 4, that will produce equation number 6. After obtain the equation number 6, compare equation number 6 and equation number 3, and after rearrange the equation in terms of delta double dot plus omega n squared theta equal to 0, we can get the equation of motions. Next, find the natural frequency of the system. Based on the equation of motion before, omega n square is equal to kr square I plus 4r square m. After rearrange the equations, the natural frequency of the system is equal to 10.488 radian per second. Next, the second question is based on the graph given. The first question is to get the damping ratio of the system using the logarithmic decrement equation. We substitute the number of cycle and also the x based on the graph, and we get del or logarithmic decrement is equal to 0.305. Next, substitute into the zeta or damping ratio equation, and we get damping ratio is equal to 0.048 for the system. The next question is to find dampened natural frequency of the system using the equation TD, or period of damped vibration, is equal to 3.5 seconds. We substitute into formula of omega n equal to del over zeta TD, and we get natural frequency equal to 1.815 radian per second. And we substitute the answer into damped natural frequency, and we get 1.813 radian per second. It also have second ways as given, but we have different answer. Both are correct. Okay, I think that's all from us. This video prepared by Ghazwani Nordin, Nurul Nadia binti Muhammad Kamaldin, and Tengku Nurul Syahada binti Tengku Syukri. Thank you.